Position x equals 3 cos pi t for t between 0 and 3. Find time when velocity is 0 meters per second. Now remember, when we differentiate, we go downwards. So to get velocity, we need to differentiate our position. So let's do that. So velocity is going to be dx on dt. So differentiating that, when we differentiate, we go downwards. So cos will differentiate to negative sign. And so we differentiate this bracket, which is pi. So we do 3 pi times negative sign. So I'm going to put the negative sign here. Pi t. Now we want to find the time when this equals 0. So we can let that equal 0. Now dividing by negative 3 pi, we're going to get 0 equals sine pi t. Now that's our angle. So we need to know at what angle on the unit circle does sine or the vertical component equal 0. So we can see here that when the angle is 0 degrees or 0 radians, that's 0. So for our first answer, we can say this is when pi t equals 0. And so that means t equals 0 seconds. So that's the first time. Second time when sine theta is 0 is here at pi. So we can say that pi t equals pi. Dividing by pi on both sides, we're going to get t equals 1 second. Now, we want answers for t between 0 and 3, so we have to keep going. So the next one is when the angle is 2 pi. So if pi t equals 2 pi, and then answering that, we get t equals 2. So I'm just going to remove the second sign so we don't confuse it for a number. And lastly, if we keep going, this is going to be 3 pi. So when pi t equals 3 pi, and dividing by pi again, we're going to get t equals 3. So our 4 answers for when velocity is 0 is going to be when t equals 0 seconds, 1 second, 2 seconds, and 3 seconds. Now for part B, we want to find the acceleration when velocity is 0. So we know that velocity is 0 at these 4 times. So now let's solve for the acceleration at each of these times. Now to get acceleration, we have to differentiate the velocity. So let's do that. So acceleration is dv on dt. And that's going to be, so we're going to differentiate this now. So negative sine differentiates to negative cos. And again, we need to multiply by the derivative of the bracket. So we're going to do negative 3 pi times pi, which will be negative 3 pi squared. And the negative will stay because negative sine differentiates to negative cos. So we're going to do cos of pi t. So that's our acceleration function. And we want to find what that is at these time values. So when t equals 0 seconds, acceleration is going to be negative 3 pi squared cos of pi times 0, which is just 0. Now again, cos of 0, that's this line here. Cos gives us the horizontal component, so that's 1. So this will just be negative 3 pi squared times 1, which is negative 3 pi squared meters per second squared. Then at t equals 1 second, we're going to have acceleration being negative 3 pi squared cos of pi times 1, which is just pi. And cos pi is negative 1. So we're going to do negative 3 pi squared times negative 1, which will be 3 pi squared. Then we have time equals 2 seconds. The acceleration is going to be negative 3 pi squared cos of 2 pi. And again, that's just coming back here. So cos of 2 pi is 1, and so that's going to be just negative 3 pi squared meters per second squared. And lastly, for 3 seconds, acceleration is going to be negative 3 pi squared cos of 3 pi. And at 3 pi, again, cos is -1. So we're going to do -3 pi squared times, this will be replaced by -1. So the answer is going to be just 3 pi squared meters per second squared.